Hello and welcome to the Slackware ARM vlog. I'm Stuart Winter, the platform architect and developer for Slackware on the ARM platform. First, I just want to say thanks a lot to everybody who's donated to the project. Some of you have also increased your donations as well. So thanks a lot for that. That's really appreciated. It helps go towards paying for new bits of hardware, either for replacements or just to add extra support for various different peripherals and stuff like that. And of course also for paying for the electricity to actually run the things in the first place. So thanks a lot for that, I really do appreciate that. Now in this video, I'm going to show you how to upgrade the firmware on the Raspberry Pi. But before we do, I had a quick look at it yesterday and realised that it's the fan is caked in dust because I haven't cleaned it since I built it, actually, at the start of the pandemic. I haven't cleaned it since then, so it's a bit dusty. So I'm going to get my air compressor out while it's still sunny and give it a good dust off, and then we'll power it up and start the upgrade process. Right, so let's first of all, let's power it down. Actually, before I do that, I'll show you what I'm just working on at the moment. I'm just building Slackware kernel packages of the Raspberry Pi kernel fork. Because one of you guys on the forum was interested in the real-time clocks on the Raspberry Pi, and my suggestion is to use the device tree overlay. But apparently that doesn't work, at least it doesn't work that well for the real-time clocks. And I'm just curious whether it's because there's something missing in the upstream kernel. So I've actually just updated the kernel build script for Slackware ARM to make it easier to build these packages. And I've updated the documents as well. So I'm actually going to push those out live onto the FTP site at some point later, probably today actually, if it finishes building. And you guys can play around with that, although I'm not actually going to test them, but I will state that as a caveat that I haven't actually tested them. Okay, so here's the Raspberry Pi. And actually, funnily enough, I had a problem with the Raspberry Pi where it wasn't working through my KVM. And of course, it's really sunny, so it's difficult to see. But actually, it is currently working through this KVM. Whereas previously, when I booted it, nothing showed up at all. And I've been having to disconnect physically the cable from the monitor and plug it directly into the Raspberry Pi. But now it seems to work. So we'll see what happens when we reboot them. One of the reasons that drew me to look at the latest firmware was because the Raspberry Pi wasn't working through through this KVM that I have here. Although everything else that I own, the Mac, PC, the Rock Pro 64, they all work, but not the Raspberry Pi. Apparently, it happens with Raspberry Pis that it doesn't. It seems to me that not everything is quite robust in the world of Raspberry Pi. But as you can see, it's currently working. And prior to this, I've been having to physically, disconnect the cable and plug it directly into the monitor. But yeah, so currently it's working. But we'll see what happens when we power it back up again. But initially, let's just log in and power it down properly or gracefully so that we're off. There we go. Yeah, so let's power that off gracefully and then we can shut it down and see what happens when we power it back up again. And if you don't see anything, I'll have to plug the cable in. Okay, it's off. So we'll just power it off with this inline switch like that. Cool. And then I will have to disconnect everything. Oh yeah. It's pretty dusty, isn't it? Yeah. Nice. Thick dust on the fan there. All right, let's take that outside and give it a good thorough blasting. Okay. So here it is. And it's going to get pretty loud. There we go, not bad. It's still a little bit dusty on the insides of the blades, but I'd have to dismantle it and then use a cotton swab to to fully clean that out, but I'm not going to do that. It's not that, I don't think it's unnecessary. Maybe at some point I will if it gets really bad, but good. That's good to go back into service. Okay, let's turn it back on. Now we should, assuming that this has worked, see some output here. Yeah, so this is the serial console for the Raspberry Pi. But do we see anything on the monitor? No. Oh, wait. So you should actually see the bootloader on the monitor, but as you can see, no. Yeah, so this is one of the issues with the Raspberry Pi. There is a boot parameter, or rather a config option for the Raspberry Pi's native bootloader to change some setting or other related to this. And I did do that, but it didn't make any difference. And as I said, as you previously saw, it was working. So I guess it just began working at some point since the machine was booted. But as you can see, the machine is clearly booted, and because you can see that over the serial console. But there is absolutely nothing on the monitor. So yeah, if you guys have any idea about that, that would be really great. But at the moment, I'm going to have to disconnect the cable from the back, and rather from the monitor, and plug the Raspberry Pi directly into it, which really is quite annoying. Oh look, hey, it's just come up. The thing is that this is nothing to do with the kernel either, so it's not like there's a kernel config option that's wrong or anything like that. You know, even in the bootloader, I don't see anything unless I plug the Raspberry Pi directly into the monitor, but at least it's working now, as you can see. So, okay, so let's log into this machine and begin the upgrade process. Okay, so I'm going to log into the Raspberry Pi and start up an X session. So, at the moment I've got XFCE configured as my graphical environment. Oh, no, I don't. I've got KDE. I can see there. Oh, this is because it's a fresh installation. I selected KDE. So at the moment, at the time of creating this video in May 2023, you'll see what happens when you load KDE. It's basically going to crash. Various parts of the KDE segfault. Here we go. There's the first one. That's KWin. So that's like part of the core of KDE and that segfaults. And you can see there, actually, there, segfaults. Some of it I think will come up in a moment, but according to you guys, this is actually to do with the kernel, and I haven't tested this myself, although I will at some point. But yeah, apparently if you use the Raspberry Pi kernel fork, KDE works. But KDE works perfectly on the Pinebook Pro and the Rock Pro 64, so with the same kernel, you know, same everything. So clearly, yeah, it's a problem with the Raspberry Pi. KDE did used to work actually, but there we go, let's kill that off. So what we'll do, I forgot that I'd done that, so let's switch to root and change the config. So x11 xinit ln-fvfs.xfce xinit, and then start x again, and this time we'll get KDE. Oh, sorry, no we won't. And this time we'll get XFCE. Yeah, there we go. So XFCE it works fine with this. All right, so let's now have a look at the upgrade process. Okay, so the first thing we'll do is go to Google. This is how to find it for yourselves. Pretty straightforward. Yeah, okay. Oh, okay, that I typed it into the search engine. So we just type Slackware ARM like that, and hit the ARM Slackware website. Oh, actually, it would have been okay to click right down there, actually. But there you go. Okay, so let's go to the installation guides on the left-hand side. And this brings you to the installation guides. So this is the landing page for the Slackware ARM and AArch64 installation documentation. Right now, in May 2023, Slackware AArch64 doesn't have a stable release. There will be one, but at the moment we're going to be using what's available, which is the development branch, which is called Slackware Current. We'll click on the current link here, and this will take us to the installation guides for the supported hardware models. As you can see, there are 3 of them right now, and we're interested in the Raspberry Pi. So we click on the instructions there. Now these are the installation instructions, but the installation instructions also contain information about how you can manage the operating system once it's installed. The way that this works to upgrade the firmware is to use slackpkg. So I'm going to search for slackpkg down here, and let's do Control and G to jump to where it is in the documents. So you'll see about managing Slackware on the Raspberry Pi. The first thing we need to do is to make sure that the system is up to date. And the recommendation here is to use slackpkg or slackpkg. So once you've followed this guide and you've set your machine up, then it's pretty easy. We scroll a little bit further down and you'll see there's a section here called regular updates. So what we're going to do now is jump to my shell. We'll switch to the root user and see one of those fortune cookies there. Okay, so let's run the first command, slackpkg update. And this will update slackpkg's knowledge of what's in the Slackware repository. Okay, so it's done that. And next is show change log. So I really do recommend that you view the change log, because there are often snippets of information in there about how to handle the changes, because not everything can be automated. So you really should look at the changelog. Can't really stress that enough. I'll cover the packages that are involved in updating the firmware on the Raspberry Pi in a moment. But just to give you an idea of why you should look at the changelog, is if we scroll down here, this package here in the A series, the Slackware A series, is called HWM, which means hardware model, BW, which means bootware, and Raspberry Pi. So HWM, BW, Raspberry Pi, this package contains the bootloader. In fact, it contains both bootloaders. Let's not get into that now, though. It contains the bootloaders, and it contains the EEPROM firmware for the Raspberry Pi and some other bootware assets that are required as well. What's important about this is that you can see this is one of the snippets I was referring to, and this tells you how to perform the upgrade. Now, this upgrade information is present inside the install guide as well, and that's what we'll refer to today. But just to let you know that generally you'll find this information here, and it's worthwhile checking the changelog. So we've looked at the changelog. Next thing is that we need to install the new packages. Now, because Slackware doesn't have a method of resolving dependencies, it doesn't have dependency management built into the packaging system. What's recommended is that when there are new packages for Slackware, is that you add them, because it could be that some of the packages that you use on your system, whether you're using them directly like Firefox or something interactive, or whether it's just part of the OS that's in the background, it could be that those packages now they depend on new software. And in the case of these two, that is the case. These packages are required for something else. So we're going to install these new packages like that. Sometimes there are no new packages since you last updated the system. It purely depends on what's been added to the repository. So in other words, if you see nothing when you run that install new command, don't be surprised. That's perfectly fine. Okay, so we've installed those new packages, and then we're going to do upgrade-all like that. This will take a while because this Raspberry Pi hasn't been upgraded for about a week or more, I think. So there might be quite a few packages to upgrade. So we've got our HWM BW Raspberry Pi package that contains the bootware, EEPROM firmware, and some other stuff. And also, with regards to the firmware upgrading process, we also need the kernel firmware package as well. So we've got these two, the HWM Raspberry Pi, and then we've also got this firmware package here. But I'm going to install everything so I get this machine up to date. So slackpkg is now going to download the packages. Well, actually, in my case, you can see it's linking them, because what I've done is, because I have a local repository, I don't download from the internet. So I've NFS mounted the repository onto the Raspberry Pi, and so it's actually linking them, so it doesn't need to download off the internet, so it makes it faster. And you can do the same thing as well. It's just a configuration option inside of the Slack package. So you now see this section here, managing the Raspberry Pi firmware. On other distributions, there is a script or a tool called RPi-update that doesn't exist for Slackware. If you do come across that on the internet, don't install it. It's nothing to do with Slackware, and it's completely incompatible. So everything for the Raspberry Pi with Slackware, it's all included as part of the operating system. It's all packaged. You just need to follow the instructions and you'll be fine. Again, we've got the bootware, which is basically the bootloader and various other different binary blobs that support the boot process, or the initial boot process. And all of those are included within this A/HWMBW Raspberry Pi package. And all you need to do with this package is just upgrade it and then run a tool to actually apply the firmware and then reboot, which we'll do in this video. The firmware for the Wi-Fi and Bluetooth is included within the Slackware kernel firmware package. So all you need to do with that is simply upgrade the package and reboot, and that's it. So it's really straightforward. Okay, so Slack package has applied all of the package updates, and it's now asking me what I want to do with some of the configuration files or the scripts that I've changed. Briefly, what's happening here is that inside of the Slackware packages, there are config files which control the behavior of particular applications. And there are also scripts like this here, this rc.4 script, which rc means run control. And this particular script is related to bringing up the operating system during the boot process. And basically the package management system has the ability to detect whether, as a user, you've changed these config files. And if you have changed them, the packaging tool drops in the newest version of this as a .new file. So in other words, if you've manually changed any of these config files or these scripts, your changes won't be overwritten by the packaging tool. But what Slack package is now doing is saying, hey, what do you want to do about it? I found that there's a newer version of these scripts or these config files. Do you want to overwrite them? Do you want to delete the new version, keep the old version? What do you want to do? So it's prompting me for some action here. I have a simple rule for this. Unless you have manually touched any of these files, then you can just overwrite the old files with the new ones. It's as simple as that. If you have touched them manually, then you'll probably want to keep your manual versions, and you can do a diff later and add anything that's missing or that you think is relevant. Now, in my case, I actually don't recall editing rc.4. I might have done. I might have hacked something up. I don't know. So I'm going to overwrite it with the new version, and that's it. There's nothing else. But sometimes there are other config files and that kind of thing that you may have changed. But again, I've only got this one in this instance. Let's return to the installation guide and the management section. So we've updated all of the packages. The kernel firmware package is all you need to do is upgrade it and reboot. But for the firmware that sits in EEPROM, you need to run this tool here, RPi-eeprom-update-D. D is basically discover. It's just telling me whether there are any updates available. So you can see that the bootloader I have installed on this Raspberry Pi is now out of date and there is an update available. To do that, I simply rerun it with the -A flag. So I'll just append A on the end there and hit enter. And there we go, it's done. I'm now going to log into the Raspberry Pi 4 as root through the serial console that I have connected to another machine. And this way you can follow the reboot process from start to finish. So we've already applied the EEPROM updates, so we just need to reboot. So we type reboot in there. Okay, so the system is shutting down now. Okay, so the bootloader is starting to bring up the system now. It's loading the operating system initial RAM disk, which is a few hundred megs in size, so it takes a few seconds to load it. I forgot to mention that inside this batch of updates included a kernel. So we're also booting into the latest kernel available. I also always recommend having a serial console on your devices because it also enables you to capture any errors as well. Okay, so let's log in. and run that RPI EEPROM-update again, this time with just -d, and it should show me that the bootloader is up to date. And that's it. Well, there we go. I hope you found this video useful. And again, if you like the project, remember that the project exists through your support. We don't run ads on the website. We don't put ads in the OS. I don't like them because I think they spoil the look of it and they just get in your way. And I don't want to use anything with ads in it, quite frankly. So nothing that we produce has ads in it. So yeah, thank you for your support. If you want to donate to the project, it's really appreciated. It helps pay for electricity, it helps pay for hardware and various other things. And the links are on the screen right now. Thanks again. I'll see you in the next episode. Take care. Bye.